So let's talk about symmetric matrix and skew symmetric matrix. When we're talking about symmetric matrix, that matrix is equal to its transpose. A is equal to its transpose, then you call that matrix a symmetric matrix. Another terminology is a skew symmetric matrix. If A is equal to negative, so you have a scalar multiplication by the transpose of that matrix. In that case, we say that we have a skew symmetric matrix. Remember these two examples. For example, matrix A, which is equal to, so here you have 1, 1, negative 1, and the second column is 1, 2, 0. I'm checking my note, negative 1, 0, and 5 is an example of symmetric matrix. Why is that? The transpose of this matrix, just switching, remember that the columns and the rows, am I right? So this is your first column and this is your first row. Now these two change their positions. It's going to be 1, 1, negative 1. The second row becomes the second column, which is 1, 2, and then 0. And then the last row becomes the last column. Here you have negative 1, 0, and 5. Well, obviously this type is the same as your original matrix. So we say that A is symmetric. Now, example of a skew symmetric matrix. I'm checking my note. Matrix A is equal to 0, negative 1, and 2. Then you have 1, 0, negative 3, and then you have negative 2, and 3, and 0. Okay. So let's take a look at this transpose. The transpose of this matrix is going to be, you have your first row that becomes the first column. So you have 0, 1, negative 2. The second row becomes the second column, negative 1, 0, 3. And the last row becomes the last column, 2, negative 3, 0. Well, if I now find the scalar multiplication of the matrix transpose by negative 1 or negative sign, this becomes plus 1, negative 2, minus 1, plus 3, plus 2, and negative 3, which is exactly the same as the original matrix. So since A is equal to negative, it's transpose the negative 1 scalar multiplication by its transpose. We say that A is called skew symmetric. Just a quick note, when you have a skew symmetric matrix, you look at the main diagonal, you see all zeros, and the corresponding entries, the reflection of them with respect to the main diagonal, they are opposite of each other. Here you have 1, negative 1, negative 2, 2, 3, negative 3. These elements, they are all opposite of each other. When it comes to a symmetric matrix, well, you have your main diagonal and the corresponding entries, they are exactly the same. 1 and 1, negative 1 and negative 1, 0 and 0.